Hi guys, I'm Yasmin and today we'll be learning about an introduction to the binomial expansion and everything you need to know about it so that you can start doing some more advanced problems. And a key component of the binomial expansion is the Pascal's triangle, which is what we're seeing right over here. It is until the fourth row, and I'm just gonna give an introduction to the triangle right now. So we always start with a 1 on top, and our rows always start with a 1 and end with a 1. So in row 1, for example, we have a 1 in the beginning and a 1 in the end. And in row 2 here, if you see this pattern, as I said, we always start with a 1, and then the middle term is the two terms on top added. So then 1 plus 1, 2, and 1. And here in the third row, we see the same pattern. We start with a 1, then 2 plus 1, 3, 2 plus 1, 3, and 1. And here in the fourth one as well. So 3 plus 1, 4, 3 plus 3, 6, 3 plus 1, 4, and we always end and finish with a 1. And we have to understand this row over here is called row 0. And all of these terms, all of these ones in the beginnings are called position zeros. And that is going to come in very important in the end. So how is this important for us? Okay, so a plus b to the second, we could have just used regular expansion. But here, for example, which we have a plus b to the power of 3, the Pascal's triangle will make our lives much easier. So let's do this example over here. We know that our coefficients are going to be 1, 3, 3, 8. Okay, so when we're doing a plus b to the power of 2, we can just use simple expansion. But when we have something like this, which is a plus b to the power of 3, using the Pascal's triangle as the coefficients will make our lives immensely easier. So let's do this right now. So here we have the row 3, which we will be using, and then this will be 1, 3, 3, 1. Okay, a little bit tight, but we can work with it. So this would be a to the third, b to the 0. Remember, highest possible, lowest possible, because here highest possible term is 3. And notice that the power of the coefficients always adds to what we're powering. So because this is 3, this has to be 0 because the sum of them needs to be 3. And then plus, a will decrease by 1, so a squared, then b will be to the 1, plus a will decrease by 1, so a1, b2. We see here that in both will give the sum of 3, and in the end, a will be powered to the 0, and b to the third. And then just to reemphasize, whenever something is powered by 0, the base will be 1. So that's why this will become a to the third plus 3a squared b plus 3ab squared plus b to the third. Okay, so how can we express what we have already done in terms of n? It's essentially really simple. So our a is always going to start with a to the n, which is our highest possible power, and our b will always start as 0. And then as we go forward, a will become a to the power of n minus 1, because it will slowly decrease by 1, and b will become 1. And then a to the n minus 2, b to the 2. And then this pattern will be followed until we reach a to the 0 and b to the n. And this will come really important when we learn about the binomial coefficients. So just to set the tone for the next video, we can find the coefficients when we have them here for us. So for example, finding a plus b to the power of 3 is really easy because we have the third row right next to us, and here we know how to find the exponents. But what if we have something like a plus b to the power of 100, for example? How will we calculate the Pascal's triangle until the row 100? It's going to be very impossible when you're doing it in tests. So our next video will show a way where we can find the coefficients for these expansions without having to resort to the Pascal's triangle.